Hello everyone, in this lecture we'll check out the most basic counting principle. So what is the most counting basic principle? Well, the basic principle of counting is when there are m ways to do one thing and n ways to do another thing, then there are m times n ways of doing both if the events are independent of each other. So let's assume we have m ways in doing something and we have n ways in doing something else, that both these two activities are independent of each other. Then we have n times n ways in doing both of them, since both of them are independent of each other. So what do I mean by independent? Well, independent means in order for one of them to happen, the other one does not have to happen. That's what independent means, and I'll show you in examples what independent actually means. But the most basic principle of counting is if we have m ways and n ways in doing two things, then we have m times n ways in doing both if both of these things are independent of each other. So let me give you an example. Let's say we have 3 different soups and 2 different spices. How many different soup plus spices we can get? Well, since these two things or items are independent of each other, basically we have 3 times 2, which is 6 different soups plus spices. Why? Well, based on the definition of the basic principle of counting, since the soups and the spices are independent of each other, we have m times n ways of things. So we have 6 different soups plus spices. Let me give you another example. Let's say we have to choose 4-digit pin numbers and each number could be from 0 to 9. How many possible pins we can have? Well, we have 4-digit pin, so we have 1 slot, 2 slot, 3 slot, we have 4 slots, and each number could be from, so in each slot we can put numbers from 0 to 9, so we have 10 options. We have 10 numbers we can put. Since we can put 10 numbers in each of the slots, so basically we have 10 times 10 times 10 times 10. So we have m times n times k, for example, times r. So it's basically 10 times 10 times 10 times 10, which is 10,000. So we have 10,000 different ways we can have a 4-digit pin, and each number that could be from 0 to 9. So as you can see, the most basic counting principle says if you have m ways and n ways in doing 2 things, if those 2 things are not dependent on each other, then we have n times n in doing both. However, here we don't have m ways and n ways, we have m ways and n ways and probably k ways and r ways. So because we have 4 activities, we have 4 slots, so what we do, we basically multiply all of them together to get 10,000 pins. So basically the definition, when there are m ways to do one thing and n ways to do another thing, and let's say we have r ways in doing something else and k ways in doing something else, q ways in doing something else, then there are m times n times k times r times whatever ways we have if the events are independent of each other. This is how we count ways to do something, or ways to do things that are independent of each other. We basically multiply one way times the other, and we get the total ways of doing both or more of them. So what happens if the events are dependent on each other? So in the examples that I just showed you, these events were actually independent. For one of them to happen, the other one did not have to happen. However, what happens if the events are dependent on each other? Are we still going to say it's m times n, or it is something else? Well, let's check out an example. Let's say we have 4 different shirts and 2 different pants. So our 4 shirts are A, B, C, D, and our 2 pants are L and M. As you can see, I have put it in different colors. But if you choose pants L, you cannot have shirt C. So as you can see, we have a condition, we have a dependency. So if I choose L, I cannot choose C. So as me having shirt C depends on whether I choose pants L or not. So as you can see, one event actually depends on another one. This is why these 2 activities, choosing a pants and choosing a shirt, is dependent. However, in the previous examples, they were not dependent, they were independent. That's why we just multiplied one event, or counting of one event times counting of the other. It was just m times n. However, we cannot do this here because these events are dependent. Choosing of shirt C actually depends on whether we have an L or not. So let's see how we can solve this problem. So basically we have 4 different shirts and 2 different pants, but if you choose pants L, you cannot have shirt C. So let's see how many ways we can have shirts and pants or different outfits based on this condition. Well, this means we have 1 times 4 shirts and pants where our pants is M. So if our pants is M, we can have 4 outfits. M can be with A, with B, with C, and with D. So if our pants is M, we don't have any problem. Plus, however, if our pants is L, we cannot have C. So in that case, we have 3 options. It's 1 times 3. So L could only be with A, with B, cannot be with C, and it can be with D. So in that case, if we choose pants L, we only have 3 options. We can have 3 shirts. So as you can see, we don't just say our pants times our shirts. However, in this case, we put a plus sign because we have a condition, we have a dependency. When we have a dependency, we have plus signs. But when we don't have them, we just multiply M times N times Q times R times whatever ways we have. However, in this case, since we have dependency, we have to have a plus sign. So basically, it is M times 4, which is 1 times 4, which as we have it right here, and it is L, which is 1 times 3, excluding C. So it is 1 times 4 plus 1 times 3. We can have 7 different outfits based on this question, based on this dependency. So if we have 4 different shirts and 2 different pants, but if you choose pants L, you cannot have shirt C, how many different outfits we can have? Well, basically we can have 7 different outfits. And why? Again, I'll say that again so you can remember, is because we have a dependency. Having C shirt actually depends on whether we choose M or L. That's why we don't get 8 different outfits, but actually we get 7 different outfits. And this is about dependency on one event on the other. So these are the outfits. We can have LA, MA, LB, MB, MC, LD, and MD because C cannot be with L. Let me give you another example. Let's say we have this example. How many outcomes are possible when 3 dice are rolled if no 2 of them may be the same? So we have this, and here as you can see we have a dependency. If we have, let's say, a dice that is 3, if we get the other one that is 3, it cannot happen. So we have 3, we have to get 4 or 5 or 6. So no 2 of them have to be the same. So how many ways, or how can we count the number of ways we can get 3 dices to roll if no 2 of them may be the same? Are we just gonna say it is 6 times 6 times 6, or it is something else? Well, I'll make it short and I'll let you think about it. The number of ways we can have 3 dices if no 2 of them are the same is 6 times 5 times 4. This is exactly like having a plus sign, but I will let you to think about it how this is similar to having a plus sign. So the number of ways we can have 3 dices rolled and no 2 of them are the same, it is just 6 times 5 times 4, which is 120 outcomes. So if we have 3 dices and we roll all 3 of them, and we want to know how many ways we can have arrangements of these 3 dices if no 2 of them are the same, or if there is no repetition, it is basically 120 outcomes, and it is just 6 times 5 times 4, because in the first dice we can have 6 sides. We have the option of 6. However, in the second one we have the option of 5 because we already used 1 and there is no repetition, and in the third one we have the option of 4. So it is 6 times 5 times 4, which is 120. 6 times 5 is 30, and 30 times 4 is 120 outcomes. And as I mentioned, this is exactly as having a plus sign, because I said in the previous slide, when we have a dependency, we usually and most of the time we have a plus sign, but 6 times 5 times 4 is exactly like having a plus sign, but I'll let you to think about it and figure out how this is exactly the same as having a plus sign. And this is about the most basic principle of counting. So as you saw, we kind of have 2 ways. So either in an example we have dependency or not dependency. If we don't have any dependency, then it is just M times N or times any other different ways we have. So it's either M times N times R times Q, whatever. If we have dependency, however, it is not like that. We have a plus sign. As I showed you in the third example, when we have dependency, when we had the dependency of the shirts and the pants, it was 1 times 4 plus 1 times 3. We had 7 different outfits. So the basic principle of counting says that when there are M ways to do one thing and N ways to do another, then there are M times N ways of doing both if the events are independent of each other. So this is it about the basic rule of counting. Let's check out another way of counting.